Welcome back, everyone. We are done with freshwater and we are moving into saltwater. The actual pacing for this week will be pretty similar to what we had last week. So we're going to cover all the earth sciencey things that you need to know about saltwater today. And then in your next lesson, we'll talk more about the environmental stuff, how humans are influencing Earth's oceans. So before we move into talking about salt water, just keep in mind I don't just literally mean salt and water. There's a lot of other things in salt water or ocean water because it is an extremely productive ecosystem. So you've got all the things needed for life. You've got gases and nutrients and other little microscopic life forms that kind of start off a lot of your food webs. The first big main idea for today is knowing the different things that affect the density of seawater. So first of all, a quick review of what density means. So if we had a bunch of different liquids, the densest liquid would end up at the bottom and the least dense liquid would end up at the top. So just kind of keep that in the back of your mind as I go through the next couple of slides. So the first thing that affects saltwater density is salinity, and that's just how salty is the water. Salt adds weight to the water. So if I just had regular water, its density would be about 1 gram per milliliter. But once I start adding mass to the water by adding salt to it, it's going to be a little denser. So if I had a mixture of fresh water and ocean water together, the ocean water would be down at the bottom because it's denser, and the fresh water would be up at the top. Now, in general, if I took all of Earth's ocean water and figured out its salinity, it would be roughly 35 parts per thousand. But as you can kind of see from that picture, there are different spots on Earth that either have higher or lower salinity. And you're going to have a couple of questions today in your assignment where you're kind of putting some logic towards why would the salinity be higher or lower in those particular areas. The second big thing that affects saltwater density is temperature. Now, where most of Earth has roughly the same salinity, as you can guess, Earth's temperatures or the ocean temperatures on Earth vary quite a bit depending on where you are. So if you're near the equator, obviously those are going to be warmer waters. If you're near the poles, it's going to be much colder water. Now, this should be weird to you. So the average temperature of polar waters is 28 degrees Fahrenheit, but fresh water freezes at 32 degrees. So if this was fresh water, it would be solid ice. But the thing is, in addition to salt making water denser, it also lowers its freezing point. So when there's salt in the water, it doesn't freeze at 32 degrees Fahrenheit anymore. It freezes at a lower temperature. It's also why we salt the roads in the winter when we think we're going to have winter precipitation, because we're trying to keep that stuff in liquid form, if at all possible, so that it doesn't freeze on our roads. So that's different temperatures on Earth, but here, when we're talking about saltwater density, we're talking more about how temperatures are affected in one particular place. So if I very, very hypothetically got to go to a North Carolina beach anytime soon, if I went there, the warmest water that I would find would be up at the surface of the water. If I put on scuba gear and I went down deep into the waters in that same location, the water would get colder and colder as we go down. That's because colder matter sinks. It's a lot denser than warm matter, where warm matter rises. Now, this is called convection. And in a normal semester, we would go way, way, way in depth with it. It's not as important here. We will go way in depth with it when we get to talking about weather. So for now, just understand warm stuff is less dense, cold stuff is more dense, so you would find it down at the bottom. Now, those are the two major things, salinity and temperature, that affect ocean water density. But there's one more set of layers that I need to talk about, and that's how much light different parts of the ocean are getting. So first of all, right at the surface, you have the euphotic or sunlit zone. Now, as the name probably gives you a hint, this is the area that gets sunlight. It's relatively warm because we just said that warm water is up at the surface, cold water down at the bottom. The other thing is it is the only layer with enough light for photosynthesis. So out of the several miles of ocean water there, and you can kind of see it in scale on that picture, this tiny, tiny layer up at the surface is where 90% of ocean organisms live. And the main thing is because of that photosynthesis, because most food webs are starting with something that needs to do photosynthesis to have energy. And then there's something that eats that plant. And then there's something that eats the something that eats that plant. So even though there's all of this ocean, most things live up in that euphotic zone because that's where they can find food sources. Now, the second layer down is called the dysphotic or twilight zone. And if you think about walking around at twilight, you can still see, but you can't see great. It's not like you can see, in the middle of the day kind of lighting. So it does receive a little bit of light, enough that you can see in the water, but it's not enough for photosynthesis to occur. And then you get down to the aphotic or midnight zone. Extremely cold, extremely dark, and as you can guess, no photosynthesis at all. Now, there are organisms that live down there, really, really cool organisms that I would love to talk about, but they do not rely on photosynthesis in order to have a food source. So they have found a way to live in a zone that they can't have it. Now, the second thing that we need to cover, so the first big one was the density and the different layers of the ocean. The next one is talking about ocean currents. So when we talk about all the different oceans, the Atlantic, the Pacific, the Indian Oceans, they're really all one big body of water. So if you kind of watch the animation up at the top, how many oceans we have on this planet really just depends on your definition. So you can have 5, you can have down to 1 because it's all the same water. So ocean currents are movement of water that mixes the ocean waters. It also transports heat, which is super important, getting that heat from the equatorial oceans up to the poles and then cold water from the poles down. It transports and mixes nutrients so that if one area of the ocean has a lot of nutrients, they're getting spread out. And unfortunately for us, it also can spread pollution from one place to another. There are 2 major types of currents. The good news is the names make it really obvious what is what. So the first one is density currents. Now, we just talked about that things that have dense ocean water are going to be found at the bottom of the ocean. So it should make sense to you that these are found they're found deep in the ocean where you would find the densest water. And then surface currents, again, the name helps you out there. These are going to be found along the surface of the ocean. These are the ones that we're a lot more familiar with. Now, there is this one giant ocean current that basically connects the surface currents up on the surface and the density currents down in the deep ocean water. So earlier when I said that currents transport heat, this is one of the ways that it does. And it's called the Global Conveyor Belt, or the GCB. So this mixes all of Earth's ocean water. No, that doesn't happen overnight. There's a lot of water there, but roughly every 4,000 years. And if you think about, the 4.6 billion years that Earth's been around, then 4,000 years is really a short period of time for all that water to get mixed. And it's powered by something very fancy sounding, thermohaline circulation. But all that means is differences in temperature and differences in salinity. So those things that we talked about at the beginning of notes today is really what powers this global conveyor belt. So this is not step 1, step 2, step 3, but I kind of wanted to talk to you about how this current works. So if we start at the equator, we know that water is relatively warm. So it follows surface currents, because that's where you would find warm water, along the surface, and it makes its way up to the poles. Well, when it gets to the poles, that water gets cold. Cold stuff sinks. Remember, I talked about that convection earlier in notes today. So the cold water sinks. Well, now it's in the deep ocean, so it follows the density currents around back to the equator. Well, when it gets to the equator, that water warms up. It rises because, again, convection, warm matter rises, and then it's carried back to the poles by surface currents. So you can kind of see how this becomes a flow of water based off of its temperature and therefore its density. That is it for today. Make sure that you do the assignment, making sure that we understand all of the things covered in notes today.